10 Chinese megacities are running infrastructure that New York City will not have for another 100 years. That is not an opinion. That is what happens when you put a city still running traffic signals designed in the 1970s next to one where artificial intelligence manages 12,000 intersections at the same time. That is what happens when you put the New York subway, which moves about 1 billion riders a year, next to Beijing's, which moves closer to 3.5 billion. That is what happens when you put JFK Airport next to a terminal built in under 5 years that moves passengers from the front door to the boarding gate through facial recognition with half the staff. New York is iconic, but iconic and advanced are two very different things. These 10 cities are not just bigger, they are smarter, faster, and more connected in ways that are genuinely hard to believe until you see the numbers. And we are going to go through every single one, starting from impressive and building all the way up to cities that feel like science fiction made real. By the end, you will not just understand why New York is behind, you will understand how far behind it actually is. Number 10, Tianjin. Most people in the English-speaking world have never heard of Tianjin, worth sitting with, because Tianjin has a larger population than New York City, and a district of people's actual homes doing something no Western neighborhood has done at operational scale. The Sino-Singapore Tianjin Eco-City is a joint development between the Chinese and Singaporean governments, begun in 2008. Every building in its 22 square kilometers is connected to a shared energy network balancing solar generation, wind power, and grid supply in real time. When one building generates surplus solar power, the system routes it automatically to a neighbor drawing more than it produces. No human decision, no delay. The district operates like one shared battery, self-balancing continuously. The numbers. Carbon emission intensity at 145.3 tons of carbon dioxide per million US dollars of GDP, classified as an advanced level internationally. One smart building achieves energy self-sufficiency of 112%, cutting annual carbon dioxide emissions by 329 tons compared to a standard building. By 2024, the Eco-City's gross ecosystem product had reached 21 times its starting figure. The port runs the same logic: automated cranes, driverless guided vehicles, machine learning systems calculating vessel delays before ships know they are running late. A 2023 Congressional Research Service report described American port automation as nascent by comparison. Tianjin is not the most dramatic city on this list. That is exactly what makes it the right place to start. Number 9, Suzhou. Suzhou is a city of classical gardens and stone bridges. It does not look like a place rewriting industrial production. But inside the Suzhou Industrial Park, factories are networked through AI systems sharing production data in real time across separate facilities. If one plant runs low on a component, a neighbor adjusts before a shortage develops. If overnight demand spikes, the entire network reconfigures before a human manager has opened a laptop. Western manufacturing has had a name for this since 2011, Industry 4.0. The gap between the concept and the factory floor is exactly where China and the West have diverged. Suzhou has the factory floor. The city's major towers embed building management AI that learns occupant patterns and adjusts climate, water, and access systems continuously. In the West, building management runs on timers. These buildings respond in real time before you notice anything needs to change. The building is paying attention, so the people inside do not have to. Number 8, Wuhan. Wuhan sits on both sides of the Yangtze River. Its answer to that geographical problem includes the Yangtze River Highway and Rail Bridge, a double-deck crossing carrying motor vehicles on the upper level and metro trains below simultaneously. That alone is a significant engineering achievement. What makes it something beyond engineering is what is inside it. In December 2022, researchers installed 114 sensors into the bridge's structure, in cables, deck, and support columns. Those sensors transmit continuously to a monitoring platform. Engineer Zhang Mengmeng stated on record, a total of 114 sensors were installed across the whole bridge. which can keep us informed of emergencies, including earthquakes, vessel strikes, and the displacement of the main beam and bridge bearings. The bridge reports on itself. Intelligent health monitoring has now been applied to every bridge on the Wuhan section of the Yangtze River. Compare that to the United States. The American Society of Civil Engineers gives U.S. bridges a C+. 42% are over 50 years old, most inspected on rotation cycles, meaning problems can develop and worsen between visits. Wuhan's bridges report every second. The metro expanded from almost nothing to over 300 kilometers of track in 15 years. 5 million passengers per day. When a metro line delays, bus routes adjust automatically, not after a supervisor calls. Automatically. Number 7. Chengdu. Chengdu uses a digital twin, a virtual replica of the city updated in real time, not as an experiment, but as the basis for actual planning decisions. Before any major road is approved, planners test it in the twin first, watching how it affects traffic years after opening, finding failure points before concrete is poured. As of June 2024, Chengdu had surpassed both Shanghai and Beijing to become the Chinese city with the most registered vehicles, Ministry of Public Security data. The city with the highest vehicle density in the country built its traffic management to absorb that growth before it arrived. Chengdu Tianfu International Airport. Construction began May 2016, opened June 27, 2021. 5 years from groundbreaking to operational. Phase 1 cost? Approximately $10.8 billion. Initial capacity? 60 million passengers per year. Full build-out? 90 million. For comparison, Heathrow's third runway has been debated since 2003 and has not been built. JFK's current renovation, underway since 2019, is projected to complete in the early 2030s. Chengdu built a 60 million passenger airport in the time it typically takes a Western government to complete an environmental review. Number 6. Guangzhou. The CTF Finance Center rises to 1,790 feet. Its elevators travel at 71 feet per second. An AI layer positions elevator cars not where they are currently needed, but where data projects they will be needed 30 seconds from now. By the time you press the button, the elevator is already moving toward you. The structural damping system works the same way. Live wind data feeds a counterweighting mechanism adjusting hundreds of times per minute. The building does not sway and recover. It anticipates the sway and prevents it. In typhoon force conditions, the structure moves less than a person standing still. Canton Tower stands at over 1,800 feet. LED systems produce 16 million programmable light combinations visible from 20 kilometers out. The spectacle is the byproduct. The actual function? A distributed sensor network monitoring air quality, temperature, wind, and atmospheric pressure across 56,000 square kilometers of the Pearl River Delta, feeding regional agencies in real time. Number 5. Hangzhou. In April 2016, Alibaba and the Hangzhou municipal government launched CityBrain. The name is an accurate operational description. CityBrain integrates data from traffic cameras, connected devices, and every transit vehicle in the city, continuously in real time. Peer-reviewed research from 2025 documents the results in pilot corridors. Average travel speeds up by 15.3%. Peak hour congestion down by 9.2%. Commute times fell by approximately 3 minutes per journey. Emergency response times improved by approximately 50%. That last figure has a documented example. A recorded test. An ambulance traveling 7 kilometers through 21 traffic lights completed the journey in 14 minutes. Without CityBrain, an estimated 30 minutes. The system calculated the route, cleared every signal ahead of the vehicle, and executed the sequence in real time. In Sydney, Melbourne, London, and New York, ambulances navigate the same traffic as everyone else. Sirens, right-of-way rules, no pre-cleared path. That is not a criticism of the paramedics. It is a description of what the infrastructure does and what it does not. CityBrain has now run for 9 years and been licensed to other cities, including Kuala Lumpur. Number 4. Shenzhen. Shenzhen did not exist as a major city until 1980, a fishing town, a border post. Today, it has over 17 million residents and is home to Huawei, BYD, Tencent, and DJI. Between 2015 and December 2017, it replaced its entire public bus fleet with electric vehicles. Every single one. 16,359 buses, all electric, all running. First city in the world to fully electrify a public transit bus fleet. Compared to the diesel fleet it replaced, 72.9% less energy per kilometer, 600,000 tons less carbon dioxide per year, fuel consumption down over 95%. Honest footnote. Government subsidies of 3.3 billion yuan in 2017 made this financially viable. Without them, the economics did not yet work for operators. State intervention was essential. London's electric bus transition will complete in 2034. Shenzhen finished in 2017. The metro runs level 4 automation. Trains drive themselves, monitor themselves, adjust schedules in real time. 6 million passengers per day. 99.9% on time. When an anomaly is detected, AI reroutes and notifies passengers before human staff have registered the event. Payment through your face, transit through your face, building entry through your face. Everything through one connected layer. This is not a feature. It is a different architecture for how a city relates to the people inside it. Number 3. Beijing. Beijing's metro moves approximately 3.5 billion passenger journeys per year. New York's subway, approximately 1 billion. London's underground, approximately 1.5 billion. Beijing moves more than both combined. The network spans over 500 kilometers, more than 400 stations, still expanding at a rate transport economists estimate would take New York's MTA over 50 years to match at its current investment pace. Beijing's AI traffic system controls over 12,000 intersections simultaneously, adjusting signal timing every few seconds based on live sensor data. Peer-reviewed studies document average congestion reductions of 25% and travel time improvements of 18% versus cities using fixed timer signals. When you drive through Beijing, you are not following a program designed in the 1980s. You are moving through a network, watching the city breathe. Beijing Daxing International Airport. Groundbreaking December 2014, opened September 26, 2019. 4 years and 9 months. Approximately $17 billion for the terminal, $63 billion for the full project, including transport links. 700,000 square meters. Designed by Zaha Hadid Architects. Farthest gate, less than an 8-minute walk. 40,000 workers. 52,000 tons of steel, under 5 years. Metro connects directly to high-speed rail. Your phone is your Metro Pass, payment method, building access, and identity verification. One layer, one interface, one continuous system. The city does not have parallel systems. It has a system. Number 2, Chongqing. There is no city built on geography like Chongqing's. The terrain drops over 3,000 feet from highest point to lowest. 2 major rivers bisect it. Chongqing built a megacity on top of it anyway, because the people were already there, and because Chinese engineers do not negotiate with mountains. The metro tunnels through hillsides and rises onto bridges 200 feet above rivers. And at one station, it passes directly through the 6th, 7th, and 8th floors of a 19-story apartment building. The train enters. It stops on the 8th floor. It exits through the other side. Families cook, sleep, and go to work on the floors above and below. In 1998, the Rail Transit Group and a private developer were both claiming the same land. They agreed to share it. Engineer Ye Tianyi's team spent 2 years on the solution. Station and building load-bearing systems separated by 20 centimeters. If the building were demolished, the station would remain standing. Chongqing has over 13,000 bridges, not a record anyone was chasing, but a number generated by necessity. A city built across rivers and cliff faces requires bridges the way other cities require traffic signals. Raffles City, Chongqing. 4 towers over 900 feet each, connected at the top by the Crystal, a 300-meter building containing restaurants, retail, and an infinity pool 800 feet above the Yangtze River. 12,000 tons, lifted into position while all 4 towers were still being built beneath it. In Chongqing, vertical movement is transit. Elevation is not an obstacle, it is the infrastructure. And that principle runs through everything the city has built. Number 1. Shanghai. On December 22, 2024, at Yangshan Phase 4 Automated Terminal, a container was lifted by a remote-controlled quay crane and loaded onto a deep-sea liner. It was the 50 millionth container processed by Shanghai Port in the 2024 calendar year. No port in history had ever done that in a single year. Shanghai has held the title of world's busiest container port for 15 consecutive years. Yangshan Phase 4 is near total automation. Remote-controlled cranes, autonomous guided vehicles around the clock. No drivers, no human coordination, no pause. The AI loading system calculates 11,466 container placements per hour. Manual calculation averages 800, 14 times faster, and it connects to over 700 ports in more than 200 countries, running predominantly on machines. The Shanghai Maglev covers 30 kilometers from Pudong Airport to the city in approximately 7 minutes, 431 kilometers per hour. The train never touches its track, it floats. The Heathrow Express runs a comparable distance in 15 minutes at 60 miles per hour. Opened 1998, not replaced. Sydney's airport rail, opened 2000, averages 70 kilometers per hour. Shanghai's Maglev opened in 2004. 22 years later, no Western city has built one. Shanghai Tower rises to over 2,070 feet. Its outer shell reduces wind load by 24%. An AI climate system adjusts heating, cooling, and ventilation independently across all 128 floors, cutting energy use by 30%. Facial recognition payment at the metro, in restaurants, at parking meters, at building entry. Transit, commerce, and identity are one layer. You move through the city, and the city processes you continuously. There is a question worth sitting with after all of this. How did it happen? Part of the answer is political. China's planning framework can acquire land, approve construction, and break ground at a speed democratic systems structurally cannot match. Environmental reviews that take 4 to 7 years in the United States take months in China. 16,000 people were resettled to build Beijing Daxing Airport without meaningful legal recourse. Speed has a cost that does not appear in the infrastructure statistics. Part of the answer is financial. China's infrastructure spending represents approximately 5.5% of GDP. The United States, approximately 1.5%. The U.S. Government Accountability Office documented that from 2013 to 2021, China provided $679 billion for international infrastructure projects. The U.S. provided just $76 billion in the same sectors. But the deepest part is structural. Many of these cities built their core infrastructure during periods of fastest growth, without a 100-year-old network to retrofit, without legacy transit authorities to negotiate around. They built everything connected from the start. Transit talks to payments. Payments talk to identity. Buildings talk to the grid. One network, not a collection of systems barely acknowledging each other. One more thing that belongs in this video, not as a footnote. The same infrastructure that halved ambulance response times in Hangzhou is documented as a tool for ethnic profiling of Uyghur Muslims in Xinjiang. The EU AI Act, effective February 2025, prohibits real-time facial recognition in public spaces. China introduced its own facial recognition regulations in June 2025. The efficiency and the surveillance cannot be separated. Western cities are not behind because they lack engineers or capital. They are behind because the systems they already have make it hard to build what comes next. and because the legal frameworks protecting individual rights also slow the decisions that would close the gap. Whether that is a fair trade is the actual question. The numbers alone cannot answer it. What the numbers can do is make the gap painfully concrete. Shanghai built a commercial maglev in 2004. No Western city has followed. Shenzhen electrified 16,000 buses by 2017. London will finish the same job in 2034. A train has been running through an apartment building in Chongqing since 2005. And Beijing built a 100 million passenger airport in the time it typically takes a Western city to decide where to put one. 10 cities, 10 systems. The concrete has been dry for years, and the gap keeps growing. If you found this video eye-opening, hit subscribe right now. We cover the stories behind the numbers that never make the news cycle. See you in the next one.